Yeah, today we can dive deep into a pretty fascinating question is design Ticketmaster, which is a pretty common questions that in the system design interviews. I think we can directly get started, and the goal of this video is to let you know what's a strong hire interview feedback for a senior level software engineer look like. I think the first thing is give the questions design Ticketmaster, pretty classic question. Cool, looks good. So I think the core idea. So usually the interviewer will only give you a very ambiguous question itself, and sometimes you need to type the question by yourself because the interviewer may not copy paste the question. So the expectation here for a senior level software engineer, the interviewer wants you to drive the whole interview. Right. It's not sufficient that you are waiting interviewers to give you some hints to guide you. But I think there is some typical templates, functional requirement, non-functional requirement, core entities, API design, the high-level design, and some dive deep questions associated. So this is some typical frameworks. So this framework is good, it's great, especially you new to the system design, it gives you a pretty good high level, the spectrum of what they look like. But I think if you want to get higher or strong higher ratings in the system design interviews, I think this framework is insufficient. The reason is not my favorite framework is it spends some time on some not that important, not that fascinating topics, right? So for example, the core entities, it's maybe 3 minutes, but in my opinion, it's totally optional. And for the API design, I usually do not cover that much because I think it's not the funniest part. I think the funniest part here, the really great part of a system design is the high level design, which is number two. And dive deep questions. So dive deep questions should be the number one, right? So there are some trade-offs. I'm going to rename it to trade-offs, right? And I usually give 3 or 5 trade-offs. And each trade-offs, there may be 2 to 3 solutions associated. So for those 3 solutions, solution A, which is benchmark or higher rating for SDE 2 level candidates. So this is solution B, which is good solution, higher rating for senior SD level candidates. And solution C, which is a great solution, a strong higher rating for senior SD level candidates, or even lean higher rating for staff level SD candidates. Cool. So yeah, that's the overview of 2 to 3 solutions. So for a successful interview, you should to let the interviewer knows that some hard is trade-offs, and for each trade-offs, you know 2 to 3 solutions that are ranging from benchmark, good solution, great solution, to really show that okay, you are very strong candidates for a senior level, right? Cool. So I think that's the core of the interview. So that's why I usually put trade-offs on the top of the structure of the interview right after non-functional requirements. And for the high-level designs, so there will be following up. So trade-offs is number one, but here I will just give some keywords of trade-offs. And based on the trade-off associated, I will give some basic version of the high-level design. And after that, I will usually go through the data flow, right? So it's usually a read request or a write request. We can choose one of them because basically we don't have enough time to cover both of them. And for the data, so the data flow itself covers the core entities and API designs or even the database schema, right? So the goal here is I don't want to spend too much on the data flow. I show data flow is because I want to let the interviewer knows I exactly know how the high level design works, right? And after that, we can spend really much time on the trade-offs again. But what we're going to do here is dive deep. So for the first version, there is not only what the trade-off itself and what's the tech stacks and what's the preference. So that's three kind of information is enough. But here, we're going to dive into the details of the trade-off. We're going to explain what's the trade-off itself, which tech stack we're going to use, and what's the pros and cons, what the consequences if we do not use the great trade-off, and why the great trade-off is a preference. So great trade-off is some universal characteristic. It will add complexity, right? And it will add like operational ops burdens, right? But it's worse because, so for example, for Ticketmaster, adding a waiting room, which is one of the greater trade-off, and adding waiting room itself is add some complexity for the whole system, right? Cool. And after the trade-offs, then it's a good time to add some more things for the high-level design, right? For a senior level software engineer, you need to at least show some characteristics that you need to assume every component is able to be failed, and you need to have a backup plan for that. But for the staff level engineers, and there is a mindset change. Like the technical part for senior and staff is not that much differences, but the staff engineer need to give a roadmap of two-piece team, right? So the staff engineer will focusing on thinking about some questions like how the system will be involved in the future, how the system will transform from system design to a platform, or how the platform will empowering like 2, 3, 4 other teams, like how it becomes the de facto standard of our whole organization, right? But I think that's irrelevant for these videos. But all in all, the first version of high-level design is it's like a toy, right? So the reason we want to talk two phrases of high-level design and the trade-offs is because for the first part, the basic version, we want to let the interviewer knows that we are very strong candidates in the first 5 or 10 minutes, right? We want to let the interviewer knows, okay, the conversation that you had with me, you're going to enjoy our conversation. And I'm not an average interviewee. I'm a very strong interviewee. It's great to give the bomb at the first time. Like I have a lot of topics I want to discussion, and I really have capability to dive into those discussions, right? So the second part is to really show the bomb. So that's the key difference is how you transform your interview feedback from hire to strong hire, right? And if you accumulated enough strong hire, it's very natural that you got up leveled, right? It's very common that if you have 2 or 3 strong hire, you are in system design and behavioral questions, then you don't need to personally ask. The interviewer during the debrief meetings will up-level you. If you interview for SDE tools, then they will up-level you to senior SDE. If you are interviewing for senior SDEs, they will up-level you to staff SDEs. The reason they want to up-level you is because you consistently shows the characteristics of the next level. You are thinking next level. So what I'm trying to say is, if you're SDE2, so the day-to-day job of SDE2 is implement individually, right? So there is a design that completed by senior SDE. SDE2 are assigned by some part of the design. SDE2 is responsible to transform a design, like a well-defined question, into implementation of workable code with sufficient testing, blah, 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 ABC, XYZ, right? So for SDE2, the system design interview, you're able to implement something, that's fine. But for senior SDE, the expectation are how different, right? There is 1 question, 2 questions, which are picked by the staff SDE in the roadmap. Senior SDE is responsible to transform the 1 or 2 questions into a workable design. So design independently, right? Senior SDE are thinking of some more important things. The problem itself is not well defined. So you need to think about a lot of trade-offs and solutions. So that's why I believe the trade-offs is the key part that you get strong hire in the senior SDE interviews. So that's some questions that SDE2 not need to think about, but the senior SDE should put into the table, right? And here is a great time to talk about the staff SDEs. So staff SDE is your mindset should beyond the engineer question itself. What if so you are building some brand new things of the whole company, and how the system will reflect in the company's earning costs? That's some questions that the staff engineer should think about. So on your different levels, what you behave in the system design interview are completely different. So a strong hire for senior SDE is probably equal to lean hire or lean no hire for staff SDE. And the strong hire for SDE2 is probably equivalent to lean hire or even lean no hire for senior SDEs. So the expectations are different. Let's directly jump into the question itself. What a strong hire for senior SDE look like? And here I will use the question, which is basically design Ticketmaster, right? And I can copy paste something. So add my framework here, trade-off. Cool, looks perfectly good. Great. So this is a new template that I use consistently. The template is I propose that I will use in this video, right? We really put like the majority of the time into trade-offs and high-level design, the two key components, the two key parts. As soon as you can talk about the data workflow, then the interviewer can assume that you already know API design, the database schema, or some basic things. If you can talk about trade-offs, then you definitely know what the database schema look like, what the API design look like. For a system design interview, Meta only have 45 minutes, which means you need to design a great system to show you senior SD level characteristics in roughly 35 minutes at most. And for majority of other companies, the system design interview itself is 1 hour. You have roughly 45 or 50 minutes. So the time management is critical. We need to intentionally pick something we want to discuss, something we need to handle, right? Oh, yeah, let's get started. For the functional requirements, usually there is some tutorials will tell you that you need to ask some clarification questions, right? Blah, blah, A, B, C, X, Y, Z. But actually not the biggest fan. So I will put this one into optional. Because if you want to get strong hire, so you need to proactively choose the most difficult systems, right? So the reason that ask clarification questions is so we already know there is 1, 2, 3 basic good, great solutions. So the reason ask clarification questions is pick the basic version or good version or great version. But you want to get strong hire, right? And you are interviewing senior SD level. So there's a non-negotiable goal that we need to pick the hardest trade-off, which means we need to bring up the greatest solution. We can talk about the basic version and the good version, but ultimately we need to put the time into the greatest version, the strong hire version. So what's the point to ask clarification questions? I already know the answer of the clarification questions. The hardest one, right? I won't invest too much time on the clarification questions. So that's the framework I propose, which is significantly different from other videos. And before the functional requirements, I usually talk about something to let the interviewer know I'm a very strong candidate. So I will say something like this. So thank you for proposing this classic and fascinating questions about the design Ticketmaster. I think this question is a great question that shows the conflicts of how to allocate an extreme traffic like a concert with absolute fairness and consistency. And another thing is how to make sure that we always have strong consistency in some critical parts. So this is not only a technical problem, but a business problem or even strategic problem to get users' trust to reflect something to the company's earnings call. So this is something that I will ask at the beginning. So the goal that I telling this is to let the interviewer know I'm an absolutely strong candidate to give a very good first impression. I'm not an average interviewee, I'm a strong one, right? The next phrase I will tell is to ask some kind of clarification questions, but it's actually not. I already know what's the boundaries of the question look like, the most hardest version. I will say something like that. First of all, I want to have some clarification of the core application scenarios, right? Is that a system that we are designing intended for some events like Super Bowl or Taylor Swift concerts, or it's more focused on like daily ticket sales of local theaters, right? So I think that's sufficient for the clarification part. So that's two different versions. And I'm asking this question, but actually I'm not asking. I will follow up some words like that to make our interview more fascinating or more even funnier. Then I highly recommend, which is the first version, which is Super Bowl or the Taylor Swift global tour system that we are designing for. This is something I will say at the beginning. To save sometimes we need to do things differently. So I'm ready to face the hardest challenge. right? After that, the interviewer usually says, okay, that sounds perfect. Let's get started. Yeah, interview is maybe very surprised that the interviewer proactively choose the harder one, right? But that's our proposal, that's our goal. And the interviewer may think about, okay, that's candidates behave differently. So after that, I will directly jump into some non-functional requirements. So what I'm going to say is excellent. So for this extreme peak scenario that I will further make a clarification of some fundamental non-functional requirements, which is directly defines what our architecture look like. Cool. I will say something like this, then directly jump into the non-functional requirements. The first of which is the most important is the trade-off between the consistency and availability, with some difficult trade-offs, right? Basically, there is solution one, which is strong consistency, where any request that cannot 100% confirm inventory status must fail. So this means that some users will see the error page, but what we need to guarantee is we cannot oversell even one ticket. Solution two is high availability, that we continue accepting requests even though there may have consequences of oversell. So with like a complex or the high ops process for refund. My recommendation here is we need to pick the strong consistency version because it's directly related to how to maintain our users, right? Okay, do you agree with that? And what I'm going to say, if we have agreement with a strong consistency, then yeah, great. We have a fundamental non-negotiable requirement for strong consistency. It's good time to talk about the performance and the scalability, right? So I think we have tens of millions of users, daily active users, DAU, and I want to be specific, like the daily active user is browse or to click the purchase. So I will do some assumptions like 10 million concurrent users, 10%, which is 1 million user, will click the purchase request at the first second when a concert starts to sell the tickets, which means we need to handle millions levels of QPS for our write path. But for the read path, the QPS may be the 10 times version of the number. For the latency, I think our goal is we need to make sure the P99 lower than 200 milliseconds. But for the booking requests, the confirmation latency can be as longer at low digit seconds, for example, 2 seconds, something like that. Do you think this is reasonable or challenging goal? And the interviewer may say, yes, go ahead, sounds good, blah, blah, ABC, XYZ. So yeah, we assume the interviewer agree with our design. And what I'm going to do next is list the functional requirements and non-functional requirements, which basically I handle as the clarification questions because I already know what the clarification questions, the answer, what they look like. For the functional requirements, we need to able to view an event that the user able to see the details, the description of the event and the real-time seat maps. So this is the first one. The second one, the users need to able to book it in real time. And after a book, the user will receive a confirmation of purchase tickets, and the user need to complete the payment within a reserved period, for example, 15 minutes or something. So that should be a reasonable functional requirements. And for the non-functional requirements, there are also some for the. It's a good time to directly tell the non-functional requirement to save time, right? The first one is strong consistency. We never do oversells. And the second is high availability. The browse functionality need to be have availability. Payment version is fine to downgrade, but we cannot lose data. And third is we need to have like extreme throughput. We need to able to handle like millions write QPS and tens of millions read QPS at peak. Also, the fourth is low latency. The P99 for read and write should be lower than 200 milliseconds. For the confirmation of write, should be lower than 2 or 3 seconds. Looks great. Yeah. So I think, yeah, have a recap of the questions that we asked. So this single question answers a lot of single, like individual clarification questions. So we can directly jump into the functional and non-functional requirement because we already know that we're going to choose the hardest version to get a strong hire for senior SDEs, right? So by seeing this and the mindset behind that is, I'm here is not only to solve the question, but to redefine the question. And my way is to not passively waiting for your instruction, but to proactively drive the whole interview. So that's a very strong characteristic for a strong higher rating for senior SDEs. Okay. And I think since we already have functional requirements and non-functional requirements. So we can directly jump into the trade-offs portion. But what we're going to do here is to give a pretty simple or basic version of trade-off, follow up a basic version of high-level design, go through one data flow, then go to the real bomb, the detailed version of trade-off and detailed version of high-level design. So yeah, so here I will use some very simple words to talk about 3 or 4, 5 trade-offs I can think about for this question. And then I will pick 2 or 3 of them to the interviewer, or even let the interviewer pick 2 or 3 for myself. There are several trade-offs that I can think about. The first one is how to handle the extreme concurrency for autonomic seat reservations, right? For example, we have millions of users to try to fight for the best seats. So how to make sure the strong consistency, not oversell, and able to handle like millions of concurrent rides. The second one is how to handle the massive reads, especially at the beginning of the concerts. We may have tens of millions of users to read the same page concurrently. So how do we handle that? And as a follow-up, since the system is like, we need to make sure to read and write. So how to keep resilient and how to like degrade, how to avoid some avalanche effects. So there are some things that maybe have problem, the read, write, payments, reserve, blah blah, ABC, X, Y, Z. And I think a critical one is how we model the seats, right? Let's see a larger revenue, for example, the Crypto.com arena. So maybe have like tens of thousands of seats, and how we modeling those seats and how we store this. It's directly related to the query performance, the granularity of the logs, and the whole overall complexity of the whole system. This is the key fundamental question. And the fourth question is like how to keep fairness, to fight for votes, like how we design a mechanism that to keep the fairness and to make sure like all legitimate users have the right to compete for a seat, for tickets. So basically, there are 5 trade-offs, and the first concurrency of seat reservation, massive reads, this is one for writes, this one for reads, and how we downgrade, and how we model the seats, and fifth, how to keep fairness to fight for votes. Yeah, so once you talk about this, then the interviewer will have a sense that, okay, this candidate know a lot. And you can explicitly say that I'm very happy to talk about all of this, but I think 1, 2, 3, or 1, 4, 5 is the most interesting or fascinating questions. So I want to dive deep for those 3 trade-offs for this interview. I want to at least dive deeper 1 or 2, ideally dive deeper all 3. So you can say some words like that. Does it sound good to you, or what's your preference? Okay, I think it's a good time to talk about high-level design. But actually, before the high-level design, I will add up more things into the trade-offs version. So after I say I pick up which ones, I will briefly talk about the solutions, but I will not to talk too much of the solution. So for example, I want to talk about the first one. I will copy paste here. The first one, second one. So read and write are critical, and maybe we pick another one, follow up. So I will show you what I'm going to do. In here, I may, before jumping into the high-level design, I may talk about very briefly of all the solutions and my review of the solutions, but don't jump into any details. So the solution 1, which is like a benchmark, which is an okay solution, is build static lock, right? So this solution is able to get a higher rating for SDE2, one workable solution. But so solution B is a good solution, which is distributed lock plus optimistic concurrency control. So this one able to get a higher for senior SDE, but it's not sufficient. Our goal is to get strong higher for senior SDE. So the solution 3 is great solution, which is virtual waiting room plus in-memory state sharding plus message queue. Plus in-memory state sharding plus message queue. This is for higher for senior SD, so which Great, right. And at that time, I will explicitly say, so in the sake of design the most robustic or most fascinating, make this interview even funnier, blah, 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 I will choose solution C. Cool. So for the second question, I will also do the similar things. Massive reads. So solution A, which is a OK solution, which is a database read-write separation and application level caching. So this is file for SDE2. Solution B, which is a good solution, is distributed cache plus CD content delivery network. So this is higher for senior SDE. So the solution C, which is a great solution, is a very thin client architecture which have real-time update functionality. So this one is a strong hire for senior. So in this, as I said, I will only say some very fundamental keywords, but intentionally not dive into the details of each solution. Here is a great time to talk about the high-level design. So we need to draw something cool. So I will use red to explicitly show that's the correct one. Okay, okay. Let me use the red color to highlight some key sentence. Cool. Let's directly jump into the high-level design. But here, I want to have a combination of the data flow to save some time, right? So it's a good time when you design high-level design, but simultaneously you tell the interviewer that what the data flow look like, what's a typical read request go through, what the typical write request. So in the Ticketmaster question itself, the read request and the write request, both requests are pretty fascinating. So we want to go through both of them. And what I'm going to do here, we have a client of our user, then it will have a get requests slash events slash ID or something. Then it could be either a browser or a mobile application. So this request will first goes to our API gateway, which is pretty standard. So we can consider this one as a simple reverse proxy of a router. Then it will go to the first core service, which is event service. And this service is the logic center of our read business. So this service is logic center for our read only request. So what I'm going to do is we'll send a request to our backend database service, which is, so in here we use PostgreSQL. I have a query like events, values, ticket, something like this tables to get all the information to render the front end, right? And after that, so as well, this is bidirectional as well. Event service may return a JSX, right, to go back to its client. So this read path is pretty straightforward, but as we discussed before, here is a big performance bottleneck that's waiting to be optimized. So we can have a label here that explicitly shows this is not a finalized version, right? Which is pretty straightforward. And for the write route, so this is the read route I want to, and here is the write data flow. I want to be explicit. So write route we have a, it's good to, so I want to be explicit to read the write routes, which is post slash booking request. It's good, looks good. And then it route to a service, which is booking service. Cool. And booking service. So when booking service receive request, the booking service will start a database transaction. So here we can, it's a pretty simple version. So we're going to use the same database here that will have something like the select. So here we'll have something like slash blah 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 for updates, right? pretty straightforward and will lock the tickets. In the transaction itself, then try to lock tickets if locked successfully and the tickets still available. So if it updates the status to reserved and create a new booking record. Then it will have external payments processor. Then it will interact. Then it will change. After payment succeeds, it will change the booking status to confirmed with updates of the database. Okay. After all, it will commit the whole database. If each step failed, then the whole transaction can roll back. 0, 1, 2, 3. So yeah, this high-level design is extremely simple, extremely naive, and is definitely unsatisfied with our trade-offs, right? But it's fun. It's sufficient for an SD2. So I will explicitly show it as higher for SD2 version. Use another color to be explicit. Cool, great. Which is super naive, right? And there's a lot of problem that we can see it. But I think this is just a bones of high-level design, so the goal is to satisfy our core requirements of strong consistency that we never do oversell. But also it creates the biggest concurrency bottleneck, which to be specific is a for update lock, which basically is a sequence of the concurrent request. So if millions of requests coming in, then the lock will, like a black hole, to swallow all our system's performance. So here's something that I want to explicitly say to the interview. And ideally, so it's fun, but there is some reveals the follow-up to core conflicts. So how to scale the read path and how to control the write path for the concurrency. So the next two questions are so those two issues will be focus of our in-depth discussion, right? But I will say something like this. Before we jump into the next following two questions, does this high-level design architecture looks good to you? Cool. But so to use these templates also depends on how many minutes that you have. For example, for Meta, the senior SD system design interview only have 45 minutes, which means you have roughly 35 minutes to illustrate all your design solutions, which means you may need to skip the initial version, but directly jump into the optimized version, right? So it's which strategy or which template you use. It fully depends on the time limitation or the interview format itself. So you need to have versatility during the interview process. So the key mindset behind, I will show the mindset behind is we want to proactively expose the issues. So this is the most critical tactic of the phrase that you don't pretend that your initial design is perfect and hide in a closet. When the interviewer touches the closet, you jump around that, which is a scenario that you want to avoid. But instead, you proactively expose the issue that you can think about and show a very positive attitude that you are proactively want to have some discussion about that, which is a key differences of strong higher and in higher feedback, right? Cool, looks good. So here is something good to jump into the detailed trade-off. This is, in my opinion, the most critical part of the whole interview. If you're unable to jump into that part, I think the ratings may not set strong hire. Do you understand? To secure a strong hire feedback for a senior SDE level system design interview, you need to at least reserve 15 or 20 minutes for this section, which is basically half of the interview, right? The first trade-off or the hard problem I can think about is the autonomic reservation under millions of concurrency. As we just analyzed in the first second of the cell, the millions of requests might attempt to modify the status of a same batch of popular seats in the ticket table. The initial version solution that we previously designed based on the database for update lock would instantly melt down in this scenario. Autonomic Great. And in this stage, there is three solutions we talk about, but the third solution, the greatest solution, is something that we invest the most time to talk about. So for the initial two, what we are going to do is handwise some part to save time for the third solution. What I will talk is the solution A, which is benchmark solution, native database pessimistic locking. So, and we may use one sentence or two sentences to talk about this. Basically, we want to talk about what the solution is, what the pros, what the cons. I will say something like this. The initial version, we already discussed a little bit that each reservation will open a transaction and want to add a lock in the ticket table. So this is pretty simple, reliable, that we like auto-sourcing all the solution to the PostgreSQL, which is a pretty time-proven SQL database. But the performance in this like millions of concurrency scenario is catastrophic. The performance of the database itself, the log manager will be the single point of failures of the whole system. Even though it's okay solution for a relatively small version of the system, but for robust and large scale system able to accept this solution. Right. So this is something that we need to explicitly say for the solution one. So here is solution B, which is distributed locking with optimistic concurrency controls. And the tech stack we're going to use is Redis plus database optimistic locking. It's a good time that we explain a little bit of the whole system, right? So when booking service will receive a booking request, it will first send an autonomic set command to the Redis cluster for each seat, such as set blank log semicolon seat semicolon ticket underline A1 blank user underline Alice blank NX blank PX blank 600,000. So something like that. Only after the service successfully acquire the Redis lock for all requested seats, so that it proceeds to the next step to interacting with PostgreSQL. So let's explain a little bit of the command, which is pretty critical. The NX is the key where ensures only first request to arrive can successfully create this key, thereby acquiring a lock. 10 minutes expiration be set it, which is like a safety net to prevent lock from being held due to a service crash or something like that. So only after the service successfully requires the Redis lock for all requests, the service will proceed to the next step to interact with the PostgreSQL, the database. So when interacting with the database, we no longer use the full update log. Instead, we use the optimistic concurrency control. Our tickets will have a version column, and the updates like a query will become like only if the version is equivalent to the version that we read, we will update it. For any reasons that we need to interrupt the operation, for example, the payment failed or like very rare the version conflict, that we need to proactively send a DEL command to release the lock. So I think this level of explanation should be fun because you talk about what distributed lock look like, what the optimistic concurrency control look like. So that's fine. It's not necessarily to jump into the details. And it's a good time to talk about some pros and cons of this solution as a review. This solution is a great progress of the architecture. It's transforms the bottleneck from the logs bottleneck from database to the Redis, which the performance is significantly higher than a database, right? But it's we sacrifice the complexity of the system. We introduce a new Redis cluster where we need to ensure the Redis cluster's availability. Moreover, even Redis may encounter the hotkey problem when handling requests for same popular events, and the CPU network of a single Redis node may become a new bottleneck. So here we need to talk about, so the key improvements is from database to Redis, and Redis performance is significantly good, but the hotkey problem is still a bottleneck. So This solution is good for the 99% of high concurrency scenario, but for Taylor Swift concerns, something like that, it's not sufficient. We need to propose a more advanced solution. So basically, we need to talk about the third solution, the best solution, the solution C, which is a virtual waiting room plus in-memory state sharding. So here we need to add up something more to our high-level design where we can talk about it simultaneously while drawing. Here it is way to Kafka in-memory state sharding asynchronous database. So this is basically asynchronous state-driven architecture, and the philosophy here is don't try to process the flood in real time, but to guide the water into a massive reservoir first. When users reserve requests reach our gateway service, we do not do any handling of the request. We just basically treat it as an event and push to a Kafka topic. And the topic will be partitioned by the event ID, ensuring that all requests for the same event enter the same ordered queue. Then after that, we immediately return a queued successfully response to the user. And on the backend, that we have a dedicated set of booking processor that before the event goes on sale, it will preload the complete seat map for popular event for the database and store it in their own memory. So that's the in-memory state map is our single source of truth, right? So for the horizontal scaling that we shard this in-memory state, for example, process A is responsible for row 1 to 100, and process B is responsible for row 101 to 200. Oh, pretty straightforward. And each processor instance works in single thread. So strictly process reservation requests according to the order in Kafka partition. And for each request, it performs state checking or updates in pure memory. So since it's a single thread with a queue, so there's absolutely no concurrency issue there, and also the latency is in the nanosecond range. So after a reservation be confirmed in the memory, the processor asynchronously writes this change to PostgreSQL for persistence storage and simultaneously publish an event to another Kafka topic to notify the downstream system such as the real-time update service that we discuss later. So as a review for this solution has near infinite write throughput, which the endpoint like Kafka will comfortably handle millions of write requests per second, and also the resilience of our system, for example, any jitter of the database, any single point of failure will not have no effect of the reception of front-end requests. The only effect is the speed for the persistent storage, right? But the cause is the complexity is the highest. So we need high available Kafka cluster and must properly handle cold start for the recovery of the in-memory state. So my ultimate recommendation is a mixture solution. For 99% of events, the solution B, which is distributed log, is sufficient. But for the 1%, like the global level events, we need a solution C. So we want to have a feature flag to explicitly in our backend to identify this solution is fall into the solution B category, this event fall into the solution C category, and so the virtual waiting room should be sufficient for 100% events. Yeah, this is a comprehensive version of dive deep trade-off discussion, but ideally you want to finish off them in 5 minutes because remember we have 3 trade-offs want to discuss. Cool. And in this part, the time management is critical. So you want to reserve more time for the solution B and the solution C, which is the two solution of our mixture of solution, ultimate solution. So for the solution A, you may use only 1 minute to talk about and handle the majority of the details. For the solution B, you want to talk about the solution B in details with 2 minutes. The solution C, you may talk about it in 3 minutes. So what I told is a comprehensive way to talk about the solution, but in a real interview, the time management is critical, the most important part. So you need to tactically handle-wise some details. Right, so this is the first trade-off that we are going to do. And the next 5 minutes, The next 5 minutes, we're going to talk about the second trade-off, which is the massive read. Here's the introduction of what we're going to talk to the interviewer. Okay, we just designed a robust way to write, but another fascinating problem is how to read. Remember, we have 10 millions of read requests at the peak. So the benchmark solution, the basic solution is the read-write separation, where the application layer browse automatically refresh every few minutes, few seconds, hoping to see the sitemap optional cache, right? So the solution one here, the very basic solution is a database read-write separation plus application layer caching. We can have database read replication plus in-application cache. So we can use guava cache or caffeine. So the idea is pretty straightforward. We route all GET requests to PostgreSQL's read-only replicas for the data's hardly change. For example, the activity descriptions, the venue addresses. So this solution advantage is pretty simple, reliable, mature, but the latency or the single point of failure is acceptable. Another issue is the freshness of the cache. So basically, the eventual consistency is fine for majority of the applications, but for our application, which have high requirement for the data refreshness, is insufficient. For the first solution, I don't want to spend too much time on that because eventually we can deprecate this solution, right? So it's good time to introduce the solution B, which is distributed cache radius plus CDN content delivery network. So the philosophy of this solution is to have different layers of cache and defense the request to as close to the user as possible. So the first layers of data, for example, the name of the event, some pictures, the statistic distribution of the revenue, will charts in Cloudflare, the CDN where latency is a couple milliseconds, and those kind of traffic will never reach our data center. So the first layer is delivery network CDN, like Cloudflare, where we cache some data like the persistent data, the description of the event, the revenues, distribution of the seats. So the latency is tens of milliseconds, which is acceptable, and this portion of traffic never reach to our data center. So the second layer is distributed cache, which is radius. We can use AWS Elastic Cache or GCP memory store. So the data is dynamic but heavily reads. So 90% of data able to be serviced by the server close to their cities, and the latency can be lower than 50 milliseconds. So the example of the data can be the real-time sitemap status, where we use a large-scale radius cluster. When the event service reach a request, it first access radius, and only when the data not found in radius, which is a very rare case cold start problems, in this case, it will query a read-only replica of our database. And an interesting topic you can talk about here is the cache warming, which is the code start, like how to warm the radius in the few minutes or 1 hour before a very hot event. So here is pretty much for the solution, but we need to emphasize the trade-off again, that this solution does not handle the most hardest problem, like how to achieve real-time update of the sitemap status. When a seat books, should we try to invalidate or update the cache on all CDN nodes worldwide? This will trigger a standing herd effect, right? And another problem of this solution is the inconsistency of the data in radius and database. So let's imagine a situation if we update database succeeded, but update radius failed. So this will have inconsistency of radius and database short term or even long term, which is a risk. At this time, you can talk about some sentence to the interviewer. I think it's a good time to introduce the third solution, which is the ideal solution in my opinion. Solution C, which is WebSocket plus real-time service plus Kafka or PubSub model. The key philosophy here is data inconsistency is a non-negotiable goal that we need to eliminate because it's directly related to the core user experience, right? What we're going to do here is we want to have a separation mode of pull and push. So the process is similar to the solution B, but the page body is provided by the CDN, while the initial snapshot of the sitemap is pulled once by the event service from Redis and sent to the client. So in this case, we are no longer have the client passively pulling state change. Instead, the server actively push the state change through a real-time channel like a WebSocket. So after the page load, then the site UI will connect with another brand new service, which is the real-time service. So let's dive into this event-driven real-time architecture, where when user load an event page, they download a persistent WebSocket connection, and the service is specifically designed to manage millions of concurrent long connections. And also, we have a static shell of HTML or JavaScript, which provided by CDN super fast speed. It has all the UI framework, but a dynamic data, for example, the site map status is blank. So when receive a new connection, the real-time service knows the user is interested in an event, which event ID is like 123, then associate the connection with a message topic. The topic is precisely the statistic shell that we talk about. We previously designed the right path, which is a Kafka topic. The booking processor publish event 2 after a successful booking, which in another word, the Kafka is like an event bus that connects our read path and write path. When booking processor processed a reservation, then it published an event to Kafka. For example, the ticket ID is ticket A1, the new status is going to be sold, and the real-time service as a consumer of the topic immediately receives this event, then look up all WebSocket connections that are following this event and broadcast this small incremental update message to all those clients. So the client side will synthesize the state by the incremental change, right? The client side there has a JavaScript application, maintain the complete state of the sitting chart locally. It's like a Legos, like incremental to make updates for the local states, thereby to updating the UI in real time. For example, since we receive a new incremental message, the seat A1 is being booked, the color of seat A1 changed to gray, indicating it's available right now. So right now is a good time to talk about the pros and cons of the solution. So the solution is pretty obvious. It's the most elegant, most efficient, the real, quote unquote, real time with the ultimate read-write separation. The efficiency of the network is still pretty good. The WebSockets avoid some massive usage of 1,000 clients performing HTTP polling. So my ultimate recommendation with no doubt solution C, even though it's the most complex one, but it's the only one that satisfies all our requirements. And here is a good time to talk with the interviewer. What's your opinion with my choice? Does it look good to you? But I believe the interviewer will look good. So after that, we can so we have pretty in-depth discussion about a read and write path. Then it's a good time to update our high-level design, right? So it's a good time to, so after update our high-level design, then we can talk about the third, the in-depth discussion. But if optimistically we still have some time, but sometime, or I would say majority of the time, we don't have sufficient time to talk about the topic topic 3. But at least with these templates, we at least can secure that we can talk about 2 trade-offs, which is still sufficient for a strong higher feedback from our interviewer for senior SDE level system design interview. So what I'm going to do is copy paste our previous design here, which is fun, but a lot of things are missing. Oh, so I can paste here, and I want to zoom out a little bit. Okay, so this one is obviously pretty bad. Okay, so the updated is pretty straightforward. So before we go into the API gateway, I will use another color to explicitly show this is some components newly added. So this is content delivery network, CDN, So it will request API gateway as well. It will first have some requests to the CDN, and when for some statistic content for the HTML, leave blank for some dynamic things loaded by JavaScript. And after that, CDN gonna request to the API gateway, right? So I will handle some details here. So cool. And after the API gateway, then it will request to the event service, which is pretty, we need to add some details. It's a stateless, able to scale horizontally. So first, the event service will query a radius, right? Radius cluster. So once cache not hit, then it will query the PostgreSQL, the read-only replica. Read-only replica. If radius cluster miss, then is the only time that the event service query the PostgreSQL read-only replica. So when after fetching the data, we'll backfill the cache and return the result. First, it will query the radius cluster. Third, it will backfill the cache and return the result. The goal of this service is speed and scalability. It will never reach the main database write operation. Cool. The hardest part for the write request, the process is completely different. First, it will route it to the gateway service. Sorry. For write request, we'll go to the API gateway first, which is the entry of our virtual waiting room. Use blue to show the write request. First, it will go to the API gateway, and it will have a gateway service. So the only functionality of the virtual waiting room is to put the request into request queue. And for the request queue, I'll choose either MessageQueue, Kafka, AWS SQS. We can partition the topic by event ID. Then each individual events, all the book requests are going to be handled by a single consumer by sequence. So what I'm going to do here, I want to make this message queue to pretty long because this one is the event boss of the whole system, right? And what we're going to do next is this, we can partition the topic by event ID. So all reservation requests by the same event are going to be handled by same consumer by sequence. So after that, it will be booking processor, which is worker pool. Cool. So the booking processor will get requests from the message queue and interact with the distributed log to acquire a log, then interact with the primary database, which is PostgreSQL, to do the transaction, and interact with external payment processor, finally to release the distributed log and push the result, either success or fail, into like a persistent store. Cool. So let's draw the line of this. First, get the request from message queue, pretty obvious. Then interact with radius to acquire a distributed log. After that, it will interact with primary database to write in the primary database with the transaction. So after that, it will interact with external payment processor, and then finally release the distributed log. That makes sense. We have another persistent storage. It can be either another radius or DynamoDB. It doesn't matter. So I'm going to use persistent storage. So it will write into the persistent storage for the results, which is pretty obvious. Cool. Let's close the data flow. So after a booking processor finish a reservation, it will send to another Kafka topic, which is the events topic, to publish an event. For example, the seat A1 sold. So it will send something back to the message queue here. This event has two consumers. The first one is our real-time service. But for the real-time workflow, I will use I'm run out of the colors. Okay. And another consumer here is persistent storage for the analytic or things or something. I don't care. Persistent storage. Cool. So this is basically the right route. So it's pretty straightforward. The message queue is most important components with the booking service do A, B, C, D, E, F, G. Then finally, there's the consumer of the real-time service. So it's a good time to talk about the real-time service, right? So the real-time service, the reason that we have a real-time service is we want to update the seat status in real time to maintain the WebSocket connection and to consume a specific topic from message queue. So the connection for the real-time service is pretty straightforward. Let's have some connection there. Delete the read and write. Delete the okay. So there is a WebSocket connection. Right. So client have a WebSocket connection to the API gateway, and API gateway will forward to the real-time service. And by the way, the real-time service can be written by Node.js or Go. And the real-time service will publish seat update events, to the real-time. So real-time service will directly broadcast the seat updates status back to the clients. Broadcast the seat updates via WebSockets to the client directly. So yeah, that's pretty much of the updated system, which have a clear distinction of read route, write route, and the real-time update, the incremental updates route, which is pretty great. Okay. And I think it's a good time to talk about our third trade-off, right? But in the majority of the time, to lean higher for SD2 version. So it's not the lean higher for SD2 version. It should be a strong higher for senior SDE version. Cool, great. To add up the font size. Cool. Yeah, it's a good time to talk about our third trade-off, right? So we have something that's pretty fascinating, where here we can have some scripts like, yeah. So right now, I think this version is sufficient for strong hire for senior SDE, but actually this system design probably can be even upgraded for strong hire for staff SDEs. And I think this video is already got too long. So I think right now is sufficient for strong hire for senior SDEs. But there are a whole bunch of other topics in my mind that I think we can upgrade it to talk about some staff SDE like mindsets, right? So I want to use a separate video to talk about that. And yeah, this video is sufficient to make you get a strong hire for senior SDE, right? Cool. At the end of this video, let's have a recap here. So this is the format that's sufficient to make you get a strong hire for a senior SDE interviews, and there's a lot of details that I cover, but the real world interview that you don't need to cover all those details, right? So it's because it's very hard to cover all of those in 45-minute interview or 60-minute interview. Majority of the time it should be 60 minutes, and you have roughly 50 minutes it's your showtime. The ultimate goal of this template is we directly jump into the trade-off as soon as possible to let the interviewer know that we are a very strong candidate and you should at least give me a higher rating in the debrief meeting after all the 4 or 5 round virtual onsites. And we use a layer-by-layer process. We handle some not that fascinating topics like the core entities, like the API designs. They are not very strong indicators to make you get lean higher, strong higher ratings in a senior level SDE interviews. So we should directly skip those parts to save some time. But we do invest a lot of time in the trade-offs, the high-level design, another trade-offs, another high-level designs, and eventually we get a graph like this, which is in details touch the topics that care the most, how to handle 10 millions of read, how to handle millions of write, how to handle the concurrency, how to handle the autonomic, and how to incremental change the view in the client's side, either the web application or the mobile application. So all in all, cool. I think that's a wrap up of the whole video, and hope everybody you have a great rest of the day. Bye bye.